Good afternoon, everyone. How are you doing today?
Good night, sir.
I don't understand. Is it that school is on break? What is happening?
No, sir, school not on break.
No,
Not,
well, it has started doing it this week, but yeah, the last day of school is winning this week, but I don't know about anything about school, anything about like the breakfast,
No, because I mean, calculus is still going on, and only 8 of us here. So I was wondering what is happening.
Well, probably some of them are
Maybe
are-
early game, maybe some persons don't read home as yet.
Okay. That is so funny because at the start of the semester, at 5 o'clock, you had people logging on, and that's why I give a 15 minutes grace period for persons who, leave office and maybe join in commute or whatever. But
man, no, probably some of them might try man, no, probably some of them might try do the what class again? The canvas, not the canvas, Electrosoft. So
sir,
you can
you must if you have a lot of background noise. I don't know if you're driving or it's the radio. Oh,
say
Mr.
that again?
Fan? I was saying that there's a lot of background noise
Yeah, go
in
ahead.
the
I'm hearing you.
background, so I'm wondering if it was the radio.
Yeah. No, I'm actually out. Hold on, let me see something. I'm actually out. Right. And after that makes it any better. Any better? Hello?
Just a little, but
Yeah. All right. Just a reminder that the syllabus is not yet finished. We have just started integration. we have the integration to complete one, and we also have the applications to integration to look at also, among other things. So I would trust that we will be committed to the task of continuing with school. We're not finished yet. That's the point. We're not finished yet. All right. I'm actually on the outside. I apologize for the interference. As soon get into the car,
You're breaking up too, sir.
Like Sergon or one device but no audio.
They're probably a calibrating thing.
Oh. Must see 5 minutes more pause and call him. All right, see him drop off there.
Tyreek, I called him already. I don't get through to him.
Oh, all right. So you're saying still I try reconnect another group.
Oh. No, sir.
Where's my bottle?
Which
See
one?
me left one back around here?
That's why mic on. That's why you mute your mic.
I'm going to.
All right. Thanks.
Hello? Anyone hearing me?
Yes, we are, sir.
Yes, sir, we
I'm
are.
here.
All right. I'm sorry about that. I just don't know what happened. Every time I tried, I don't know if you saw me coming in, but every time I would enter the lecture room, the Zoom would kick me out. I apologize. I'm actually in commute. So I was asking earlier, how are we with what it is that we have been doing in terms of the integration? I sent you a document, and in the document, it contained a few more questions than we would have completed in class on Thursday, I believe. So my question to you is, how are those going? Were you able to look at the document? Hello, somebody?
Yes, sir, look at the document. The
Okay,
document.
thank you, Lotto. Okay, thank you. Thank you, Lotto.
And also find two
Yes, sir.
questions as only find in my past papers, yeah.
In your past, okay, good. So I want you to hold on to that, because that's where I was going to take the conversation to a little later. All right, do me a favor, Lotto. Those questions that you found, I'm going to ask that you keep them close by, because I'm going to ask you to project those for me pretty soon. Right? I'm going to ask that you project those pretty soon. But let me go. Crosswell, you were saying something earlier that what?
Yeah. Yeah. No. I was saying in regards to Thursday. I didn't see him the first time, so I would just look at him for just actually the short time that I had because there was a disruption in the kind of what happened there lecture.
What? What are you saying? I'm not here. I don't understand what it is that you're saying to me. What are you saying?
I really need something.
You weren't in class on Thursday?
Basically, I wasn't able to go online Thursday because of there was a disruption in the network. So
yeah, man, I got that. But hold on. So have you guys received the recording from last class?
I wasn't finished, sir.
Okay, Crosswell, I heard you in terms of you not being able to get on in the first part, and you did say that in the lecture. But I'm asking you now, were you able to access the recording from last class?
That's what I'm trying to say. Yeah, I was trying, that was what I was trying to say. That I saw it on and I basically looked at it.
Okay, I don't think you answered my question. Let me go back again. How many of you got an opportunity to go through what it is that I did last week? That was what I asked. How many of you got an opportunity to go through? I sent all the recordings, and I also sent you the very night the document that we worked on. I think we did up to maybe question 8 or question 9, and I think I sent like 14 or 15 questions. My question to you, how many of you were able to go through the document, the recording, the document, what was said last week?
So I didn't go through the recording, but I skipped through the document and looked at the answers.
Okay.
Going down from 8.
Going down from 8. Go.
Sir, I went through the document and the recording.
All right, great. All right, anybody else? Am I to assume that you?
Sir, are you talking the one you sent in WhatsApp?
Yeah, man. The one from last class.
Okay, yeah.
Okay, all right. So my question now is, well, not question. Observation. It sounded as if you guys were very busy, and that you never got a chance to look at the document I sent you on the integration. Is there any truth to that for those of you who may not have done it? Hello, 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 hello. Can you respond to me, please?
Yes, sir, because
It's one of you.
from last week I didn't really pay too much attention on it because of got busy, but I looked at it, but it was a long time. I can say that.
Okay. All right. Aye. So I was really hoping that, and which is why I made an effort, even after class at 10 o'clock on Thursday last week, to sit up to get the additional questions in for you. It was with great hope that you would have used the weekend or part thereof to go through the additional questions so that we can be moving on. Now, really and truly, feeling uncomfortable now to try and move on because of the lack of
Sir, excuse
participation.
me. Is
Go ahead.
the because I went through it and I'm one is there any I don't see any too much of a difference on what we were doing in class on Thursday. So if they went through recordings, I think
Yeah, man. My concern is not there for you, Lotto. I know you would have gone through your stuff, but I'm just saying. I asked a question, and from recollection, I'm hearing from Coswell, I'm hearing from Dane, not Dane, Daniel. I heard from Tariq. I hear from you, and somebody has answered. But there are other students in the class. Tonian, Sovan, Courage, Dane, and among others. So just answer me. Me just want to tell you.
Even so, I just stepped away from the device for a bit, so I didn't get an answer if you asked me a question.
Oh, I was just asking if you got a chance to go through what it is that I sent last week, both recordings and both recording and the document with the additional questions that I sent.
Oh,
Didn't
sir.
get
Yeah,
one.
no.
I didn't
Yeah,
want to.
Tony went through it, probably because you're driving and you can't see the chat. Tony went through it.
Oh, yeah, man. I'm not looking at the chat. Yeah, that much. I'm not looking at the chat. All right. Thank you, Tony. All right.
Sir, I wanted to
Just a
ask a
word of.
question.
Oh, go right ahead, please. Go right ahead, son.
I remember one of the classes I came late, but you were saying something about Devon House and going through past papers. So I was wondering if it's this week you're talking that would
No, man. When school
happen.
closes. When school closes. No, when school closes.
Oh,
This is just in preparation for the exam, right?
I was going to refer to this week closing. Before you stop me, I was going to say if it's this week when school closed Saturday, or it's going to be one of those days next week.
One of the, it will be next week because I teach on a Saturday. I have a foundation class on a right. So technically we'll have our class today, Thursday, God's willing, today and Thursday, God's willing. And we will have conversations in the WhatsApp group. We won't close out fully until the 20th, I believe, from the college. That's when we have our general staff meeting. So I wouldn't necessarily. I mean, what we could do is we could meet online on Tuesday, and we could also meet online. Come on, help me out. Today is it the 13th or the 14th?
13th. It's the 13th, sir.
13.
13th, right? So that means next week Tuesday will be the 20th, 21st, 22nd. So with an agreement from you, we could meet Tuesday, Thursday of next week.
Sir, I was thinking closer to the exam because initially you had said, after Christmas season, whatever.
No, man, I think that's for the past paper. I think so. Want to
excellent. That's for the past paper. No, man. So remember, I'm not finishing us. I want to sneak in an extra week for next week, and then we'll still meet. So after we meet, my recommendation is to meet next week Tuesday online, next week Thursday online, and then after the Christmas break, we can plan a Devon House past paper session or past paper sessions leading up to the exam.
Okay, sir.
Okay.
So it wouldn't be a one-off thing. It would be something that is going to be consistent. So my recommendation is next Tuesday, Thursday we'll meet online. So if I get the go ahead from you, knowing that we'll close off officially on the 17th, which is this Saturday. So Saturday coming with my last weekend class for this semester. But I'm also going to be meeting the time that I have will be shared equally between you and my Foundation 1 class. Now, when we meet next week online, hopefully it is to wrap up the syllabus. Then you go off on your Christmas break, eat up all of the food and get some brain energy. And then after the celebrations, now we could meet, at least once a week or maybe twice, up until we go back, for the exam. So we can plan that over WhatsApp. Am I clear right there?
Yes,
Okay,
sir.
sir. Yes, sir.
Yeah, so probably, sir, you need to ask the time for Tuesday, Thursday. But so persons will be home, what time they prefer, or something like that. So nobody will be.
Am I to assume? Can I assume correctly that no other lecturer away from your math one here is having a
You're
class?
assuming correctly
Yes,
so
sir.
far, sir.
You're
Yes,
correct.
sir. You're correct so far, sir.
So I'm the delinquent lecturer. That's what you're saying?
No, sir. You're the
Alright.
clearing.
The exceptional.
I feel loved. All right. So what we could do on Tuesday next week, God's willing, is not to meet at 5 o'clock since some people are still getting home. So you want us to do it at 6 o'clock or 7 o'clock?
I'm okay with 6.
Because
I'm okay with 6. So
we could,
if 6 or 6 is better. Anyone is better.
all right. All right. What about the others? For those of you who cannot leave before 5 o'clock to get home or don't drive.
Sir,
So 6 o'clock then. Yes, go ahead, please.
will the recording be uploaded?
Go ahead.
Will the recording be uploaded? Because I don't have time next week, Tuesday. I have an event.
Okay. So Tony, let me ask a question. Have I uploaded all the recordings?
Yes.
Yes. So therefore, this won't be an exception. Yeah, man, the recordings, and that's why I want to do the do next week online also, so that I can have the recordings. Yeah, man. So I did say that I was going to book the times, so which is I was asking about the times. So I'll book the times and upload the recordings as per usual. It's just the ones, the past paper sessions that may not be recorded because we're going to be sitting around on grass, in dirt, And if anybody has a different venue, I was only suggesting Devon House. If you have anywhere else that is central, please you can make recommendations. There's another place that I am having in mind, but we can make recommendations and we can see how best we can work on that. The final draft of the timetable is not out yet.
No, sir, I don't see any.
Oh.
All right, so we're still seeing our exam on the 10th, the Tuesday, the 10th of January.
Yes, sir.
All right, good. So we're working for the 10th then, right? Worst case scenario, it can only be on the 9th. So let us work for the 10th. All right. Now, so as a quick reminder for what it is that we did last time around, when I'm integrating, there are 8 rules for integration. There are 8 rules for integration. And the rules will not be as rule number 1 or rule number 2 or rule number 3. So you won't get something to say this is rule 1 or rule 2 or rule 3. There are 8 rules, basic rules, and those rules must be known and go through as you are doing the questions, because I can give you a question that will constitute 4, 5, or 6 of the rules could be embedded in that one question. All right, so you have to remember. But one of the most important rules to integration is that you're going to be adding 1 to the power, and then you're going to be dividing by the new power. X to the n will therefore become x to the n plus 1 divided by n plus 1. Are you okay with that so far?
Yes, sir.
Yes. All right. Now, So if n is -1, what do we do? If n equals -1, what do we do?
Would reciprocate the function and set the n positive.
Okay, and so when we integrate now 1 over x, what do we get?
One over x.
No. Remember, 1 over x, it will be x to the -1. Remember, the condition says x cannot be equal to -1. However, if x is -1, there's something that we need to do. Think back. Stay into the document, look back, think back on it. If x is -1, if you have x to the -1, and yes, Daniel, I hear you, you reciprocate, you get 1 over x. The integral of 1 over x dx becomes what? The integral of 1 over x dx becomes what?
Sure.
Anybody remember the natural logarithm?
All right, so when I look at the rules, it says that the condition that x is greater than 0 is added because only positive numbers have logarithms, and for negative numbers, we use absolute value of x.
And have what? And we introduce a logarithmic function.
Yes, sir.
Good. So when I'm integrating 1 over x dx, I'm going to have ln x plus c. So remember, the condition is when x is -1, you're going to be using the natural logarithm function. So you're going to have the ln function that you're going to be using. Only when x is -1. If x is not equal to -1, you're not using the ln function. And remember, it's not in, it's ln. It's the natural logarithm function. You only use the natural logarithm function when you're integrating a function that is raised to the -1. All right? Because when you add 1 to the power, -1 plus 1, you're going to get 0. And technically, you cannot divide by 0 because you're dividing by the new power. So you're going to have x to the 0, and anything raised to the power 0 is 1. So you're going to be having 1 over 0. But a 0 cannot exist in the denominator. So therefore, you now have to use a natural logarithm function. Remember, only positive numbers have logarithms. Only positive numbers have logarithms. So therefore, you cannot, what does that mean? You cannot evaluate the logarithm of a negative number. Math error, it does not happen. Not yesterday, not today, nor ever. All right? So only positive numbers have logarithms. And therefore, when you have x to the -1, it's going to be equal to ln x plus c. Now, you will also see on the document that I would have ln the absolute value of x. And remember, the absolute value of a number is always a positive number. So the absolute value of -1 is going to be +1. The absolute value of -10 is going to be +10. The absolute value of +10 is +10. All right? Why is that so, sir? Because logarithms, only positive numbers have logarithms. So I cannot have ln -1. That does not exist. So once it is that the values are negative, then I have to use the absolute value of those numbers. Have to use the absolute value of those numbers. All right? Okay, so those are 2 rules so far. There's another rule that we spoke about, that when we are finding the integral of 1, we never ever say 1 dx. What do we say?
X plus c. When you find your integral of 1, you simply write it as dx and not 1 dx.
Very good. So when I'm finding the integral of 1, simply, and of course we have a plus c here. Yes. So you simply go ahead and write the integral of dx. If I see 1 dx, you are going to be penalized. It's redundant. All right. Now, what it is that we've been looking at since last week are what are termed indefinite integrals. indefinite integrals. Now, when I'm doing an indefinite integral, I must have my constant of integration. What is used to denote my constant of integration again?
C.
That would be K, sir. Oh,
It will be C. No, not K. It will be C. When we move into other differentiations, other integrations, such as differential equations, you're looking at the integrating factor, we're going to be using K as something else, right? And K as a constant. But for the definite integrals, indefinite integrals, we're going to be using C as a constant of integration, all right? So those are 3 rules so far. Let us look at one of the other rules. It says, if I'm integrating f of x plus or minus g of x, what it means is that I'm going to be integrating individual functions. So if I have ax squared plus bx plus c, and I'm integrating, it's going to be the integral of ax squared dx plus the integral of bx dx plus the integral of c dx. It means that I'm integrating individual terms. So if I'm integrating individual terms, and each term is an indefinite integral, it therefore means that I'm going to have my constant of integration for each of the terms. True or false?
Sure.
What is that? Hello? Are you following what I'm speaking about, students?
Yes, sir. It's been a rule 7. I think you're at rule 7.
Right. Remember, no, I'm not projecting anything on the screen. I've already projected and given you copies of the rules. I'm going to go into the rules to reinforce. And I'm reinforcing the rules in particularly because I get the sense that quite a number of you just didn't get the opportunity to go through the session, the recordings. Incidentally, there are 13 of us here. And on the system, I have 24 students. So I'm just saying. All right. So almost half of the class is absent. Let's hope that you're accessing the recordings asynchronously. Okay. So one of the things that I want you to recognize, which is why I'm moving to that particular example, is that when we're integrating individual terms, I want you to be mindful that my constant of integration, my plus C, is not going to be equals to 5C. It's just going to be equals to C, because a constant is a constant is a constant. All right. And of course, if you have a negative sign, I'm combining 2 rules now. If you have a negative sign, you're integrating negative f of x dx. It is plausible for you to just factor out the negative sign, and just integrate the dx, the f of x, or the f of x with respect to x. And of course, have your plus c, and then you multiply by the negative number. Similarly, if I'm integrating, say, for example, I'm integrating 3x squared, I can factor out the 3, integrate the x squared with respect to x. When I get my answer, I multiply through by 3. Those are 2 rules that I combined in one just now. Do you understand what I'm talking about? Does it make sense?
Yes, sir.
All right. So let us see how many rules we've gone through. So we looked at the rule. When I'm integrating, I'm adding 1 to the power divided by the new power. That's the first one. I also looked at when the power is -1, that I'm going to be introducing the logarithmic function. I also spoke about the integral of f of x plus or minus g of x, that I can go ahead and integrate individual functions, plus or minus, individually, and then combining my answer as a final one. That's number 3. Spoke about the integral of a negative function. You can factor out the negative sign and integrate the function and then distribute the negative sign throughout the function. I also spoke about integrating a function that has a multiple you can factor out that multiple and integrate the function and then multiply by that multiple. So we've gone through 5. So there are 3 more rules that we need to look at. Oh, sorry. No, we also looked at a 6th one. When we're integrating 1, we don't say 1 dx, we just say the integral dx. All right? We just say the integral dx. And there are 2 others. Can you remind me of those 2, please? Can you look at the document and remind me of the other 2?
Sir, that would be the
Integral of the natural
exponential.
exponential function.
Oh, right. So when you're integrating e to the x, the integral of e to the x is e to the x times the differential of e to the x, times the differential of x, and then you're going to reciprocate it. So let me go again. The integral of e to the x dx is going to be e to the x. Remember that the differential of e to the x is also e to the x. So the differential of e to the x is e to the x times the differential of the power. The integral of e to the x is also going to be e to the x, but you're going to also now multiply that by the reciprocal of the differential. You're multiplying that by the reciprocal of the differential. So if you have, for example, e to the kx, I think that's the example I gave, the integral of e to the kx dx is going to be e to the kx times the differential of kx is going to be k, then you're going to reciprocate k, so you're going to end up with 1 over k times e to the kx plus c. True or false?
True, sir. That's the one we have.
Right. So just remember, when you are integrating the exponential function, you are going to be putting back the exponential function, but you're going to be multiplying it by the reciprocal of the differential of the function, of the power, right? Power function. All right, very important. And there's one other that I'm missing. Which one is that? I think I gave you 8. So we're going through 7. Scan through and tell me which one we're missing.
Sir, that would be the last one. The negative.
Oh, that was the last one. Okay. So we've done those. All right, thanks. Okay, now. So what I'm gonna ask, are you all comfortable with what it is that I just went through again? I just helped you to go through the document that I sent out last week. And it's going to be very important because we're now going to be going through some of the stuff. Now remember when we did the differential of the square root function? If I have the square root of x, when you convert the square root of x, what do you get?
X to the power of half.
Thank you very much, Courage. X to the power of a half. No, they are very mischievous and they love to give you functions to integrate that contain the square root sign. So if they gave you the square root of x to integrate, this is what I want you to do. Similar to the differentiation, you're going to be converting it. So you're going to convert your x, your root of x, to x raised to the half power. And remember, the rule says you add 1 to the power, then you divide by the new power. So in that particular example, I'm going to ask you to write for me. Write for me. The integral of the root of x dx. So we're integrating the root of x dx. You can write the square root sign, write one x underneath it, dx. So the integral of the root of x dx, you're going to convert the root of x to x raised to the half power. You're converting the root of x as x raised to the half power.
So you can go again with that, please.
Then I'm asking to write for me the root of x dx. The root of x dx. The square root of x dx. I'm integrating the root of x dx. But the first thing that you need to do is to convert the root of x to x raised to the half power. The first thing to do is to convert x, the root of x to x to the half power. So what we're going to now do is to integrate x to the half. And integrating x to the half, we're adding 1 to the power, dividing by the new power. When I add 1 to 1/2, what do I get as a fraction? Hmm? 1.
3/2.
3/2. Very good. I'm going to get 3/2. Now, I'm going to divide by 3/2. I'm going to divide by 3/2. So what I'll end up getting, remember now, when you're dividing by a fraction, you have to invert and multiply. So instead of 3/2, I'm going to have 2/3. I'm going to flip it. And then, matter of fact, you tell me, what would be my final answer? Go ahead now. Now that I've helped you with the integral, the conversion, I want you to now finish the integral for me of the root of x dx and tell me your final answer. Finish that for me, please, and tell me your final answer.
Sir,
Yes, Papa.
I recognize a complex function on my part. So you would have the x, and to that power you would have 3/2, and all of that is based on 3/2 again. So it appears in the expression twice, and I'm wondering if that's the right term.
Yes, you're adding 1 to the power and dividing by the new power. So whatever having the power is what you're going to divide the function by. So always expect that when you're integrating. You're adding 1 to the power and you're dividing by the new power. But what I want you to do, go ahead, Courage.
No, I just want to say what I got.
Yeah, man, right. I'm saying, go ahead. What did you get?
2x to the power of 3/2 all over 3. Plus 6.
Excellent. Excellent. So the task that I just gave you a while ago, I wanted you to go ahead and to show me that you know how to invert and multiply in your fractional form, because for integration, expect to get these fractional forms. Expect to get these fractional forms.
Sir, for my thing, I got 2/3 times.
Hold on, Crossroad. Hold on, son. Hold on.
Yeah, what are some there? Are you still there?
Yeah. You can't see it, just
Sorry, Crosswell, you can go ahead now, please. I'm trying to connect to another device. Go ahead, Crosswell, please.
Sorry?
You were saying something and I asked you to hold on.
Oh, no, it's all right.
All right, no problem. All right, very good. Yeah, but incomplete though. You don't write it as 2/3. Explain that message, Crosswell, please. You heard what the answer is supposed to be, right?
Sorry, can you repeat the answer for me, please?
Supposed to be 2x to the 3/2 over 3.
2x plus text 2x.
Sir, my question is how the coefficient of x becomes 2 and moves from the denominator.
All right, mute for me, Daniel.
3/2.
All right, so forgive me, I am distracted now because I am seeing where the final timetable was posted, and I'm gonna ask Rockstone. Yep. So I think that's confirmed then. The final timetable is posted. It did say final assessment timetable. Yeah, it did say final. So I think we are where we're supposed to be in the afternoon on that day. All right, so I never normally give students any information about times of exams because I don't want anybody to say that I told them a time and I missed I gave them the incorrect information. So I don't give students time for the stuff. So I'm going to ask that you refer to your timetable. I don't think there's a change based on what it is that you communicated to me, but the final draft is out. Final draft is out. All my big one for do. Want to shame me. I'm not going there. I'm not going to do what I'm supposed to do. I'm confident about what it is that I've done so far. If the exam would have been tomorrow, I'm sure you guys will be able to go in there and answer questions and still pass the exam, even though we don't finish. But I want to give you the best opportunity to get an A. So please, now go doing the stuff and don't shame me. All right. I'm coming to you, Daniel. I'm trying to. All right. So what it is that we're doing, we have to invert. We have to invert and multiply. All right. So write for me, please. All of you can just write this for me, please. in particular, Daniel. So you're going to have x raised to the 3 over 2, x, and in the power, you're going to have 3 over 2, x raised to the 3 over 2, and then you're going to divide by 3 over 2.
Yeah,
Then you're going to divide by 3 over 2. All right? Now, when you're dividing by 3 over 2, you see that 3 over 2 in the denominator?
Yes.
What do I do? Okay, what is the inverse of 3 over 2? Let me ask you that way. What is the inverse? 2 over 3. So you're going to be multiplying the numerator by 2/3. You're multiplying the numerator by 2/3 because the denominator, when multiplied by 2/3, will give you 1. Because a number times its inverse equal 1. A number times its inverse equal 1. So 3/2 multiplied by 2 over 3 is going to give you 1. So technically, you're multiplying the whole function by the inverse. So it's going to multiply by 2/3. And when you multiply two fractions together, the numerators are being multiplied, and then the denominators are being multiplied. So in the denominator, you will have 1. So that 1 is going to be multiplied by 3. And in the numerator, you're going to have x to the 3/2, sorry. And that x to the 3/2 is going to be multiplied by 2. Am I clear right here, Dan?
You lose me from your start. From your start.
I'm not following you, sir.
Yeah, from when you start with the inversing, it kind of sound disconnected. So can just ask to repeat it.
Sir, let me tell you what I have, sir. I have x to the power of 3 over 2 multiplied by 2, and that's based on 1 multiplied by 3, the
Very
denominator.
Good. Excellent.
All right.
Excellent. So you got that from what I just said a while ago, right?
Yeah, but you would have to explain it, sir.
No. I'm just asking you a question. If you got that from what I just said. So you asked the questions, I'm asking if you got that from what I just explained a while ago.
Right, yes, sir.
Okay, got you.
All right, so
sir, I have x to the power 3 over 2 divided by 3 over 2 times the inverse, which is 2 over 3. It's a number that is inverse is equal to 1. That's where I'm at.
Right. So when you multiply, so you're multiplying the numerator by 2 over 3, and you're multiplying the denominator by 2 over 3. You're multiplying the numerator by 2 over 3, and you're also multiplying the denominator by 2 over 3. When you multiply the denominator by 2 over 3, what do you get?
1.
Very good. Excellent. And then now, when you multiply the numerator by 2 over 3, the 2 is going to be multiplied by the x to the 3/2, and then the 3 is going to be multiplied by the 1 in the denominator. This thing is giving me.
All right, so let me just get it straight. So the 2/3 that is the inverse, is that still a power, or is that being used as a fraction itself?
A fraction question.
Okay. Yeah, just want to clarify that.
The power is the power is just going to be the power is just going to be the 2/3 that is raised by the x. I'm trying actually as I speak to you. I don't want you to think that is not right. I don't want to write. It's just that my writing tablet, well, the computer. Okay, now it's going through.
Well, sir, I have a question.
Yeah, go ahead.
Okay, sir. So you would have left after you get 1 in the denominator, in the numerator, x to the power of 3 over 2, and that is multiplied by 2 over 3, and you put the 3 in the denominator with the 1. That's how the 3 got in the denominator? I'm assuming.
Yes, sir.
Oh, okay. So.
In as much as so I love to take your questions, I'm going to say something and I don't want it to be misconstrued. But you know, Sir Shan will have to just tell you. I'm not in the business to hurt people's feelings. Never have, never will. But you see what we're discussing here? It's not calculus 1. That's fundamentals of mathematics. It is cause for concern that if our foundation is not strong, we're going to have difficulties, especially for calculus 2. And even though one may say, yes, sir, we could focus on the calculus 1, no, that we don't know. Yeah, we can do the calculus 1, but I tell you, it has been my observation that students who get 50 and 51 and 52 for calculus 1 are the ones who normally fail calculus 2 because the foundation is not so strong. So how do we improve on that? Thank you very much for asking me. It means that we need to practice. When sir sends a question, now go tell us he must do all of the questions the same night. But a question a day takes the fear away. A question a day takes the fear away. My mathematics can't be done and be treated as you're reading a textbook or you're reading what do you call it? One of them other books, a social studies book or something like that. It is very it requires a lot of discipline. All right, so I'm going to ask you to help me help you develop that discipline. Please and thanks. All right. It's not one thing the other, you know. I'm just going to change this stuff because it's not responding the way I want it to respond. So that was a question. The integral of the root of x dx is the same thing as x raised to the 1/2 dx. Recall, x to the n, the integral of x to the n dx is going to be equal to x to the n plus 1 over n plus 1 plus c, my constant of integration. So now I'm going to say the integral of x to the 1/2 dx is going to be equals to x to the 1/2 plus 1 divided by 1/2 plus 1 plus c, which is going to be equals to x to the 3/2 over 3/2 plus c. What I'm saying to you is that I multiply here by 2 over 3 and also have to multiply the numerator by 2 over 3.
Yeah.
And when I multiply...
Yeah, 2 over 2, sir.
Not anymore. Thank you. When I multiply 3 over 2 times 2 over 3, that is going to be equal to 1. When I divide by 1, I'm not changing. And I keep saying, this is what they tell you when we go to local school, we have to invert and multiply. No. And when we understand what they mean by invert and multiply, none of my teachers, not even when I was doing CXC, not even when I was doing A-level math, they were able to tell me that. It's just a, It's just a rule that you're supposed to know. It's not until me go the teacher place, and I'm doing some stuff and I'm teaching teachers how to teach. And it's like, okay, aha moment. All right, so that's what it is. So what I'm saying to you now that the denominator here is equals to 1, what I'm having in the numerator is 2/3 multiplied by x to the 3/2 over what?
1.
Over 1. Very good, over 1. The rule says the numerator is going to be multiplied by the numerator. Numerators multiply each other. Denominators multiply each other. That's what the rule says every single time. So the rule is going to be now 2x to the 3/2 divided by 3
over 3
plus c. And that's your answer.
Yeah, that actually make more sense. So
Are there any questions? Any other questions? Please ask them now. Don't wait until afterwards they may find themselves into difficulty.
Sir,
Go ahead for me, please.
you can go over the second to last step, please.
Then go over the who?
Second to last step.
The second to last. All right. Tell me what in particular. Who is this, Chedi?
Yes, sir.
Second to last step, the one with the blue?
Right.
Okay. So you understand the step before that, Chedi?
Yes, sir.
All right, good. So all I'm now doing, hon, is just to do the multiplication. Just remember, when you're multiplying two fractions, it's the numerator times the other numerator, and the denominator times the other denominator. Get that, dearest?
Yes, sir.
Yeah, man. Every single time. Once you multiply two fractions, and you may say to me, but sir, when now I multiply two fractions, yeah. Let me show you the two fractions are multiplying, the two something they were multiplying. This is one something, that's one fraction. See the other fraction here? But this x to the 3/2 is this x to the 3/2 right here. Sorry, right up here. And this 3/2 times 2/3 is the same thing as 1. So instead of writing all of that something gibberish there again, I'm just going to write the 1. So I'm multiplying two fractions. Remember, any whole number can become a fraction by dividing by 1. Any whole number can be written as a fraction. Just simply divide it by 1 and you're good to go. Understood?
Yes, sir. I have another question there.
Go ahead, hon.
I understand why you multiply by the inverse, and that's fine. But I think what's bothering me or confusing me is when you get to the next step, why are you multiplying the denominator by the 3 if you already multiplied by the inverse from the step before?
Right. Okay. So that's the point I'm making, hon. Look. All right, watch me. This is from C-set mathematics. And for those of you who didn't do the C-set math, you'd have had to do the foundation concepts 1, 2, and 3.
So remember to have some old people in here.
Young girl like you, I call yourself old. What about your business? Young, fresh somebody like you. All right. No, but even though Lotto, those of us who did.
So you're talking about 21 years ago now.
Yeah, but I mean, at roughly the same time, we did the exam. Well, even before then too.
So, but you do every day.
Yeah, but hold on, now. Geez, I'm further. All right, stop. Move on. Geez, anyway, move on. And I just did a rough calculation of when I left high school and it don't look pretty. So this is going to be 1/2 plus 2/3. So I keep saying to my students, let us work the numerator first. We're going to work the numerator first. Numerator. And the numerator is 1/2 plus 2/3. The LCM is going to be 6. How many times can 2 go into 6? 3 times. And 3 times this one is 3. How many times can 3 go into 6? 2 times. And 2 times 2 is 4. 4 plus 3 is going to be 7. And that's 7/6. Let us look at our denominator, DEN. Our denominator is as is, 4/5. So when we put in both of them together now, Chedi, we're going to have 7/6 divided by 4/5. But in little school, Chedi, them tell us you're going to invert and multiply. Them don't tell you why you have to invert and multiply. Teacher Shandy is not telling you why you have to invert and multiply. I want to get my denominator equals to 1. So therefore I have to multiply by the reciprocal of 4/5, which is the inverse. And the inverse is going to be 5/4. You just flip it. You follow me, Chedi?
Yes, sir.
Good. And anything we do in the denominator, I have to do in the numerator. Because you see, dividing both sides by this, that is as if I'm dividing by 1. Because 5/4 can cancel out 5/4, talk truth.
Yes, sir.
Yeah. So it's as if I'm not really doing anything to the stuff. Remember when I started up the class, I say some people cook and put, when you go to hotel, good 5-star hotel, you'll never find a pimento in a cream of pumpkin soup.
I think that's what I said.
Yeah, because everything them put in, them take back out. All right? So that's exactly what I've done. I have now introduced 5/4 into the equation. Me introduce 5/4 into the equation. I'm taking it back out by multiplying the numerator by 5/4. No, Chedi and others, when I multiply 4/5, when I multiply 4/5 by 5/4, I'm going to get what number?
1.
1. Every single time. Yeah, man, never get 1. So watch teacher now. So I'm going to get 1. I'm going to get 1. So what this works out to be now is going to be 7/6 multiplied by 5/4 divided by 1. Uh-oh. But when I divide by 1, it's the same thing as just the numerator alone. Talk truth.
It's been a long time since I do that type of calculation there.
Yeah, but guess what? Very needed now. So the point I'm making is, when you're going to little school, they always tell you to flip and I cannot, in clear conscience, I can't just tell you to flip and multiply, because that's not what it is that you're doing. You're actually multiplying by the additive inverse, but the multiplicative inverse, sorry, which is a reciprocal. I have to teach you the right thing. I have been victim of some very good math teachers, don't get me wrong. I think I came across some very good math teachers, but they taught how they were, they taught me how they were taught. And I cannot teach my students how I was taught when I know the right thing. Sometimes some teachers say to you, no man, carry it over the equal sign. Anybody ever hear one teacher tell you say carry it over the equal sign before?
Yeah. I always hear that.
Yeah, but you can't carry nothing over no equal sign.
So I said since we come here.
Say it again.
I said it once when in this class as well. And you said no, nothing like that.
Absolutely.
What is
Because
that?
That is how we were taught. No, catch me 20 years ago, or 25 years ago. Let me just start teach. Yeah, man, I tell them, I say, carry over the equal sign. No, sir. As you get more seasoned in the stuff, you have to speak the correct jargon. You have to speak the correct stuff. You're using inverses, the additive inverse and the multiplicative inverse. That's what you're doing. So I have to speak the correct terminologies. And trust me, I went to a session recently with some teachers, big teachers. And one of them sitting around my table talk about, no, all you do is carry it over. I said, excuse me, miss, carry what over where? I said, no, don't speak like that.
All right. So we have to do what we need to do so that we can have our students understanding and doing very well. All right. So Chedi, that's what we do. If you look at the purple, what we're doing is we are multiplying by. So when they say to you invert and multiply, this is what they're talking about. They didn't tell you the full story, but that's why we had to invert and multiply. They didn't tell us the full story. Why are we inverting and multiplying? So we can get the denominator equals 1. Anything the denominator be, we're going to invert and multiply that, and we're going to end up multiplying the numerator by it as well. Trust me. So yes, Roswell, your observation was correct. Not Roswell, sorry, Daniel. Your observation was correct. The same something in the numerator is going to be the same something in the denominator when you go to the x to the 3/2 over 3/2.
Sir.
Yes, Papa.
Can I tell you that this is the first time I'm hearing about this procedure in maths?
Absolutely, I'm not surprised.
Yeah, because when you mention them something, sorry, it sounds like some foreign language, that talk. Because those terms sounded, they sound wrong.
Yeah, man, and that's fine, and that's fine, and that's fine, and that's fine, and that's why I'm here. That's why I'm here. I'm here to teach you the correct stuff. Many of you, if not already parents, will be parents, and will have your little ones who will be doing exams. And how it's not like when media do common entrance. Oops, I just dated myself. Right? So people could have just beat the chest 2 times and just circle one answer that was there. No, you have to give a reason now for your answer. You have to explain what it is that you're doing now. So it requires so much more for the students. In order for you to be in a position when you get your degree to help your son or your daughter, your nephew, your niece, and the other members of your community, you have to understand. You can't do calculus 1 and calculus 2, and then you have your own child come and say, how do you do this quadratic equation? I say, oh, you never did know. Then we wonder how you pass or you get a degree, right? So you have to be able to understand, so it is that you can help others. And it makes life so much easier for us too. All right. Do me a favor now, Lotto. We have 15 minutes left. And you say you found 2 questions. Can you, okay, I was going to ask you to do something for me, but I'm going to ask you just to, let me see if I can. How did I do this the last time, Lord? I did something like this? No. How do I do that? I go to insert and I put blank page. Nope. Wrong. Move. Undo. Okay, I think I remember what I did. I went here. No, that's not what I want. I went somewhere like here, so.
Sir, I would suggest you press enter until you reach the next page.
No, but if that's what I was doing, and then the thing was moving. Right? So all of that moving. It happened the last class, and I did something, and and I keep forgetting, that I don't open just one thing. See, keep going up there. All right, never mind. You know what I can do? I can just go ahead and just create a new document, and then I can merge both of them, and I'm selling the PDF. So if you think it's only one way to skin a cat, there are many ways. So you can go on. Here, Papa. All right, so come down here. So now. All right. You find a question, Lotto?
Yes, sir. It's on this. Oh, 1 minute now.
All right. So I get through them. All right. Can you read the question for me, please? Oh, sorry. What past paper question is it? Let me just do this first before.
2016.
Let me just get another page first, please, before come out of the drama. All right, good. 2016.
Let me see. 27 December 2017.
All right. Bam. Bam. Nope. I need to go to this one. BECEMBER 2017.
No, sir. Wrong one. 2016. August 2016. So many open here.
That's fine.
August 20. Yes, August 20. Go up on the top.
All right. Can you read the question for me, please?
It is x squared.
Hello?
X squared.
The integral?
Yeah, yes, sir. The integral open bracket x squared plus 3x plus 2 close bracket dx.
All right. Easy one, too. How many marks?
4 marks.
Oh, geez. Easy something. Let's go. I want you to watch me. I want you to watch me. It's not hard. Watch me. This is what the rule says now when we talk about f of g plus or minus g of x. We're just going to integrate everything in one shot. Integrate that. Come. What we're going to say now, we're adding 1 to the power divided by the new power. Tell me what to write.
3x squared. No, 3x cubed, but 3x cubed over.
Hello? Come on, hold on.
Which one, sir?
When you integrate in x squared, what you get?
X cubed.
Right.
Cube, sir.
X
Over,
cubed
over 3.
Over the
3. Good. Plus
3x squared.
Good.
Over squared. Over 2.
Over 2.
Plus 2x. Plus c.
Easy 1, 2, 3. 4 marks. 1 mark, let's so. 1 mark, let's so. And get a mark for that. And get a mark for that. So you have a constant of integration. If you don't have a constant of integration, you're getting penalized and easy only 3 marks. Easy 1, 2, 3. Now you look at that, guys, and tell me that those 4 marks weren't easy marks to get. Next question.
So where the cube come from?
You add 1 to the power divided by the new power.
Okay.
So the next one is
I'll come in, honey.
December.
I'll come in. Recall x to the n. My system is acting up. X to the n plus 1 over n plus 1 plus c. All right, so always remember that. Same August 2016?
No, December 2017.
BECEMBER 2017. Go ahead for me. The integral?
Integral of 9x squared. Open bracket 9x squared minus 5x minus 3 close bracket dx.
Look and see what I have on screen is what you have
that
on paper.
3 marks.
That's correct, what I have on paper?
No, sir. No, sir. Everything is in brackets. Everything. So remove the bracket from the 5x and put it where the 9 is. Open bracket at 9x squared.
Oh, so what sign go between here, so then? Plus?
It's a minus. Yes,
That's
sir.
it?
Yes, sir.
All right, good. Not a problem. Same patient. Next patient, rather, same treatment. Different patients, same treatment. What I'm going to be doing is adding 1 to the power, dividing by the new power every single time. This thing not hard. Add 1 to the power, divided by the new power. Adding 1 to the power. 9x cubed over 3 minus 5 whole.
5x x squared
over
2 minus 3x plus c.
And then now
clean it up a little.
Right. And then what I will do is to say 3 into itself goes 1 time, and 3 into 9 goes 3 times. And then now I will just put it as 3x cubed minus 5x squared over 2 minus 3x plus c. Answer. 3 marks. Let me show you. Let me show you a trick. I'll come into you, Hon. I'm going to show you a trick. You get 1 mark for that. You get 1 mark for having all of that. You get 1 mark for having that. They don't give you a mark for the C. But if you don't have a C, they take off one of these marks. All right? So they give you 3 marks. So if you have those 3 things shown, but you don't have the plus C, they're going to take off one of the marks. All right? Part B to the question says what?
1 over, let me go back. I'll come back to check. The integral 1 over x minus 2 dx. Let's see. X minus 2 dx. Yes, sir, that's it. I do that one, sir.
Trouble. Any suggestion?
Sir, I didn't do
Sir,
that one.
I would suggest the logarithmic.
Lack of who, sorry? Say that again?
No, I won't say it again, sir. It's hard to pronounce.
Integral?
Yes. No, not that. I-N or L-N.
The logarithm?
Okay.
Yes, sir. And the absolute value of x minus 2. And that would be multiplied by x plus c.
So you're saying then that this could be the same thing as x minus 2 raised to the negative 1 power. That's what you're saying, right?
Yes, sir.
Okay. Would he be correct?
Not sure, sir.
Yeah, so when you convert x minus 2 to the negative 1/2, what do you get? Doesn't that give you 1 over x minus 2 to the positive 1? Yes, no, maybe so. Somebody say yes.
Yes, sir.
And which is the same thing as 1 over x minus 2, because once it is at its raised to the first power, it is the same thing. Now my question to you, is this the same thing as that?
Yes, sir.
Yeah, man. So when we integrate now, okay, so these are where they're all turned up, and I will just go ahead and just erase them. What do we get from there now? Talk quick before time run out. What do we get? Somebody was saying it earlier. When we integrate in a 1 over something function, what do we get?
Sir, that would be ln and the absolute value multiplied by x plus c.
All right. Okay. Very good. So All right, so I hear you. This is going to be ln x minus 2 times the differential of the x minus 2, don't? And then you're going to reciprocate it. What's the differential of x minus 2? What's the differential of x minus 2, class?
1.
Hmm?
1, sir.
1. And then when you reciprocate 1, you can get 1, don't it?
Yes, sir.
So it could be 1 over 1. So the answer is really ln x minus. Tell me says 2 marks for this.
Let me check. I think it's let me just double check, didn't I? Yes, sir. 2 marks.
Okay, because I'm couldn't give nothing more than 2 marks. I would have slapped them.
And they
silly.
have one, yes, they have one for 3, but it's 1 over x squared minus 2.
Yeah. That one is going to be different. So, and it don't have no upper limit or no lower limit, right?
Let me check again. So
You don't see no number up top of the S.
no, sir. It's just like the other ones going
It's
down.
just elongated S. It's just
Yes, sir. That's
right.
why I say that one. No number there.
All right. So this is 1 over x squared plus.
No, let me just check again. Or it's minus. Oh, that's the same one. Minus 2. Minus 2. So it's minus 2, sir.
So this is going to be ln x squared minus 2 times what?
2x?
But are you going to use it by the 2x or are you going to
2.
1 over 2x?
1 over 2x, yes.
Okay. Answer. Is that difficult?
Yes, sir. 2x.
No, it's not difficult, man.
See.
It's not difficult. All right. It's now 6:59. I'm going to pause. I'm going to ask you one thing for me, please. Grab your past papers. Grab your past papers. Any question on integration, indefinite integral? Sir, how do I identify the indefinite integral? You don't have any powers. Sorry, not power. Limits up top. So indefinite is when you just have the elongated sign. A definite is when you can have an upper limit and a lower limit, right? So I don't do the upper limit and the lower limit one with you yet. God's willing on Thursday, we're getting started. God willing on Thursday, we're getting started. Because it's not hard enough. It just means you have to go a little bit more work, right?
Sir, I have some question, not to cut you in the class the rough one.
Yeah, no problem. No problem, AB. Just take your time and go through.
Sir, I want to do my test 3 so I can finish, but I don't know. I don't want to touch it because the answer I have on homework question still that I can't write properly for the answer.
But did I fix that issue for you the other day though? Was it fixed?
I don't. It's I just don't do it. I just don't.
I'm going to
don't do the test. I don't do test 3 yet.
All right.
The answer setting. I'm just waiting to do that and then I'm finished.
All right. So after class, I'm going to take a little 5, maybe get a bite or 2 or 3. And then you can send me a WhatsApp and I will, look at it. Just take a screenshot of the picture
Of the question.
Of the screenshot of the picture. What is important is each question that is populated on EducaSoft has a number code to the top right, I believe it is. Make sure that when you're screenshotting or taking a picture of the stuff, I can see that number, because each number is unique. Each question has a unique number. So I need to make sure that both numbers, the questions corresponding when I'm searching for the question online.
Because when I try to put it in, it says it's incorrect.
Incorrect, yeah. I think it's just the way that you're putting it in. I think you're doing the correct stuff. It's just the way you're putting it.
Some of the ways work. For me, when I was doing Unit 2 and I use the slash sign like to divide the thing, whatever you're doing, so you have a let's say a root, square root thing to do. I used to use the slash, but I realized that with some of it doesn't work. Even when I was doing the Unit 4 last night, some of the questions in the practice, I realized that it don't matter what I do, it not working. So I just move on and leave them alone. The 1 and 2, then when we not get the full mark for, I just skip over them because I'm gonna waste my time.
But Unit 6 as one question. But what I realized with Unit 6, Unit 6 have some questions in the practice that don't from the other units.
Yeah, all of them. They have like 1 or 2, like they have like Unit 1. I realized that in Unit 2 quiz, it has something coming from the limits, but I think it was don't remember if it was the differentiation. I don't remember which one.
Yes. Because that one you're referring to is called L'Hopital's rule. And L'Hopital's rule to limits include some differentiation, which is why I skip. I'm going to go back to limits, I think I told you that before. I'm going back to limits, because I don't finish limits yet. But the other parts of limits now would be differentiation. So I had to wait until I do differentiation first before I go back there. So thanks for reminding me. That's not even 5 minutes worth of class. So on Thursday, God's willing, here's a plan of the day. We want to maximize these 3 hours on Thursday. We want to maximize those hours. So we're starting at 7. I'm gonna look at I can look at L'Hopital's rule for you, just to finish off the limits fully now. L'Hopital's rule is not difficult, as I said before, it's still limits, but it's just we're gonna use differentiation. I could send you something. It makes sense, Mr. Nick. I'm not gonna read it. So
persons will read it.
All right. So I can send you something on L'Hopital so you can read for me in the meantime. And then I will look at L'Hopital's. Then I'm going to come back to the integration. There's 1 or 2 little things with the integration. And then now I need to talk about the integration under the curve. Remember that little build up we're talking about with the hotel and the house and know how far down to go and so forth. I was driving past some places today where I was going, as a matter of fact. And I can tell you, I went to the National Stadium today. That's where I was connected from. And I passed Priority House, the same place I was talking about, and I looked at the monstrosity of the building. The car park is underground, and it just reminds me of the mathematics. We are going to be doing all those calculations from next week. Not next week, on Thursday, which is going to be an application to the integration. And then one of the other applications to the integration is going to be some differential equations. Right? Don't worry about it. We're wrapping up. I think by next week, Thursday, God's willing, I should be finished with the syllabus. I'm very confident that I can finish come next week. Thanks for those of you who commit to being here. For those of you who can't be here, like T, who says that she has a difficulty, please to access those recordings so that you can still catch what is supposed to happen. And then we meet for past papers. You must pass the course. Don't shame me. Don't shame me. I beg of you. Right? Yeah. So finally, find questions on the integration on your past papers. Work them. We're going to come to class and we're going to box them off and then we're going to move on. All right? Peace and
Okay.
salutation. Thanks for coming out. Later.
Sir,
Go
sir,
ahead.
before I
Go
go,
ahead.
sir, you asked about the recordings. If all of them are there, I don't think the one for the last class was there. So unfortunately, I couldn't make the last class.
All right, you're breaking up. You're not breaking up. You went very low. One class who?
Sir, can you hear me now, sir?
I hear you better now, yeah.
Yes, sir. I'm saying you asked about the recordings, if all of them are there. I don't think the one from last class was there, sir. Unfortunately, I couldn't make it to last class.
So you're not seen last recording?
No, sir.
Anybody see the last recording? All right. Let me, don't move. I went back and I looked at something and I saw where it said something was failed. Hold on. Let me just, hold on. Don't move. What am I looking for? YouTube. Phone, my channel.
2x. 2x. Okay. 2x.
It's there. 10 people viewed it. No, it's not there. It's there. All right. I mean, I can resend the stuff, but I'm seeing it there. The one that I uploaded. But anyhow, I mean, I can. It doesn't kill me to do it again. But I'm seeing it there. Calculus one. What I'm seeing is that my foundation one, the one that I uploaded, foundation one, says to me that that upload failed. But anyhow, I can look back at that one, Papa. Not a problem. All right. Peace and salutations. Be good and be safe. Thanks for coming out.
All right, sir. Thanks.
Okay. Take care.
So this is you know one, then I want to mess up there. You know, 1 to 4. Then I want to 4 at see there? Next question.